Let's go. Hello and welcome back to Calc1. So the lecture is on 2.4, infinite limits. And we are talking about limits that have infinity as an answer. So we have two one-sided limits and then the overall limit. That's three limits, and if the answer is infinity, they fall into this category. So limit x goes to a minus plus minus infinity, or limit f of x as x goes to a plus. So these are the one-sided, or limit f of x as x goes to a. This is from both sides at the same time. So these are the ones that we are discussing in this lecture. And the example for this you have already seen. The best example to look at is for the f of x equals 1 over x, and then also 1 over x squared. But let's talk about this one first. We draw the function. And then the red approach towards 0 is the limit as x approaches 0 minus from the left of 1 over x, and we have negative infinity as the answer. The blue approach from the right is giving us positive infinity as the answer, and we write limit x goes to 0 plus of 1 over x, and that's going to be positive infinity. Now, by the theorem, we know that if these guys match, we have overall limit of what they have, and if they don't match, the overall limit does not exist. So we will write that the limit as x approaches to 0 of 1 over x does not exist because these red and blue do not match. One is positive, one is negative infinity. Now, we are going to take a look at another function, which is 1 over x squared. And we're going to do exactly the same, left, right, and then overall. The graph would look like this now. And if you are thinking in your head, how does he know? I memorized it. That's, yeah. Approach 0 from the left. We have our limit of 1 over x squared to be positive infinity, right? The blue approach is the limit 1 over x squared as x approaches 0 plus from the right is also positive infinity, and the overall limit 1 over x squared is positive infinity as x goes to 0. So this is another example of limits. Last class I said that limit is a fancy way to find the y value for the function. So as x approaches 0, y value approaches positive infinity, and that is the answer in this case. That's it. Yeah. Now we do application of this, and that is Let me put it here, a title. Vertical asymptote. You guys learned in pre-calculus that certain functions have a vertical line that function cannot cross, and you call that line vertical asymptote. Now we are going to define that vertical asymptote through a limit and give it its true definition. So a function f of x has a vertical asymptote if the limit x goes to 0 minus is equal to plus minus infinity, or limit f of x as x goes to 0 plus is positive and negative infinity. So if either of the two one-sided limits is infinite, you have a vertical asymptote. So now we know that f of x equals 1 over x has vertical asymptote at x equals 0 because, and you can pick any of these, limit of 1 over x as x goes to 0 minus is equal to negative infinity. This is actually the proof. This is the entire problem. Over here, this is a problem solved using this definition. So the problem, the function has the vertical asymptote at this point because the limit at that point was infinite. It's very simple. You just sit and learn the red definition. And now we look at the spicier examples, obviously. So if you have f of x equal to, say, x plus 4 divided by x squared minus 16. How do you find vertical asymptotes from pre-calculus? How do you find vertical asymptotes in pre-calc?
X by itself.
Nope. Yes. So pre-calculus states, and it's a dangerous statement, that if denominator is 0, there is a vertical asymptote. So in pre-calculus, you used to set denominator equal to 0, and whatever numbers you get there, it's a vertical asymptote. Well, we have to retire that statement now, because in this case it doesn't work. This calculation, denominator equals 0, will give you candidates for vertical asymptote, and some of them will turn out not to be vertical asymptotes. So what you know from pre-calc, you need to upgrade now, because we have more powerful tools to test these things. So a problem like this would not be fair in pre-calc, because in pre-calc the narrative is denominator equals 0. That's the vertical asymptote. Move on. Let's see what happens here. We get our x squared equals to 16, and then x equals plus minus 4, giving us two numbers, -4 and +4. So these are the candidates. Let me write that in blood. So these are the candidates. Now, I want to test and see. The only way any of these or both are vertical asymptotes are if they fit this red definition. If they don't fit this, you have to scrap it. If it fits, it's a vertical asymptote. So that's very simple, right? Which is why I stressed over and over again, in calculus, do not study problems. Don't waste your time. Studying problems in calculus is waste of time, because as soon as you memorize how to do a problem with polynomial and exponential function, and I hit you with either ln or a tangent, you'll be clueless. The only thing you have to learn in calculus are these things. This over here assumes all possible functions. So you cannot study this example here and say, yeah, I'm good to go. You will never be good to go in calculus if you study examples. You first have to learn this, because these are universal truths that work in every problem. This is how you do problems in calculus. So now, if I am to use this to solve the problem I have below, I am going to just apply it by saying limit x plus 4, x squared minus 16, as x approaches -4 from the left. This is it, and you have to solve this. All right, we're going to factor. We know previous section taught us the tricks, right? So x plus 4, x minus 4. These cancel. And we have x approaches -4 from the left. So now we have -4 minus 4. It's -1/8. Is this an infinity? It could be if you write it this way, right? But no. Oh, you just got it, right? All right, fine. Here one more time. Only if you write it this way would be infinity. But it's not infinity. It is -1/8. Therefore, -4 is not a vertical asymptote. -4 will be just an open circle on the line. If you graph this function on your TI-80 whatever, you will see a missing pixel at -4. And we can actually do that experiment. I think I'll be able to put this thing under the document camera. Let's just quickly calculate the other one. So now we're going to work with 4. I have limit x approaches 4 from the left or the right, doesn't matter. And we still have x plus 4 over x squared minus 16. Factor cancel. And we get to the statement which gives us 0 in denominator. Luckily, we know how to solve this problem by graphing. This is shift where?
Right.
To the right. 4 units. So our standard graph 1 over x will be shifted 4 units to the right. This is number 4. And we see that the answer is negative infinity. Yay! Because the answer is negative infinity, 4 is the vertical asymptote. So we only have one vertical asymptote at x equals 4. X equals negative 4 is not a vertical asymptote in this case. So I have a vertical asymptote at x equals 4. Make sure you never write this because it's a 0. VA equals 4 is a meaningless statement in mathematics. It means nothing. So never write that. The equation for the vertical line is x equals 4. So make sure that you do not write this here. Never, ever, ever, ever write like this. Ever. It's not a vertical asymptote, so we don't care. This section is about vertical asymptotes. However, because I am the best, I'm going to graph this function now. So graph for x plus 4 over x squared minus 16. I know that there is the vertical asymptote at 4, and I know that there is the open circle at negative 4 because we got negative 1 over 8. So negative 4, negative 1 over 8. The line goes like that and like this. So open circle at negative 4, negative 1 over 8. Because the limit gave us negative 1 over 8. And over here, vertical asymptote at x equals to 4. No coughing. I'm going to graph this now on the calculator and get this displayed. So let me first make sure that this thing works. People think it's a microphone or it's a light or something. They mutilate it all the time. And if it's broken, I don't have to bother them. So we have open parenthesis x plus 4, close parenthesis, divided by open parenthesis, x squared minus 16, close parenthesis, and then graph. If you are using standard viewing window, this is all you're going to see. This is important because you clearly see that there is no vertical asymptote at -4, right? There will be one right here. And it will look just like this, right? It's like those heartbeats, right? It goes asymptote, 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 right? And then no asymptote. The asymptotes are good, right? Anyway, I know it gets worse. This is level 2. So now I'm going to go into window, maybe. There we go. And put x minimum at -5 and x maximum at -3. Hold on. There we go. So as I change the window to zoom in to -4, this window now is -5 on x minimum, -3 on x maximum, -1 on y minimum, and +1 on y max. There's your missing pixel at -4, 1/8, right? So this is the problem where you learn that we need to now upgrade what we know from pre-calc 1, and that is that 0 in denominator sometimes produces vertical asymptote and on other times produces just an open circle. So you just have to be careful. The way to distinguish between those two is to learn the definition. When you run calculations, when you apply definition to your function and to your candidates, the numbers that you get when you set denominator equal to 0, the numbers that you get, or infinities, will tell you, hey, it's a circle, or it's a point, right, that it's missing, or it's a vertical asymptote. So it's one or the other. Bueno? Good. Now, all I need to do to make both of these into asymptotes is to change this 4 into anything else. Any other number would not cancel, and you would have 2 vertical asymptotes in that case. So why is it open circle? It's open circle because there was a term to cancel, which reduced the function. So there's that as well that you have to pay attention to, right? So if you know the definitions and theorems, the rest of Calculus 1 is going to be a joke. If you study examples, good luck, right? Because I can twist this example, I can swap these, right? And a lot of other things could happen. You only need to know one thing, and that's the definition. You grind through that definition and you're done. Now, you've probably seen it before, especially if you took your calculus in high school, that when you say limit, no limit, the denominator equals to 0 is a vertical asymptote, make sure that you are checking that every time, because as you can see, it could be open circle as well. And that's it. I'm done. Bye.